What is a stroke? It's the movement of the piston from top dead center to bottom dead center. Calling an engine four-stroke means its engine cycle has 4 strokes. A 4-stroke gasoline engine uses internal combustion, so those 4 strokes must include the 5 key events common to all internal combustion engines: intake, compression, ignition, power, and exhaust. Let's look at a simplified model. The intake stroke starts with the exhaust valve closed, the inlet valve opening, and the piston at its highest point, top dead center. It starts to move down, increasing the volume above the top of the piston. This makes pressure inside the cylinder lower than pressure outside. This higher outside air pressure forces air-fuel mixture into the cylinder. The piston reaches bottom dead center, the inlet valve closes, and the intake stroke ends. Both valves stay closed as the piston leaves bottom dead center. The piston moves up, squeezing the air-fuel mixture into a smaller and smaller volume, which compresses it. That makes its temperature rise, and that makes combustion easier. Just before the piston reaches top dead center, the next key event occurs: ignition. Burning expanding gas generates the force to push down the piston. This is the power stroke that drives the engine. The piston now moves from bottom dead center to top dead center. The exhaust valve opens, and the piston pushes out the leftover gases. Let's look at the cycle operating. Intake takes in air-fuel mixture. Compression squeezes the air-fuel mixture into a smaller and smaller volume. Ignition. The mixture under pressure is burned. Power. Burning expanding gases push the piston down, creating a power stroke that turns the crankshaft. Exhaust. The piston moves upward, forcing burned gases from the chamber. All 5 events occur in this order in each of the engine's cylinders.
In one 4-stroke cycle, the crankshaft does 2 revolutions. In those 2 revolutions, how many strokes does the piston make? It does 4 strokes. Out of those 4 strokes, how many actually produce energy? In one 4-stroke cycle, only 1 stroke out of 4 delivers new energy to turn the crankshaft. In a 2-stroke petrol engine, lubrication occurs by mixing oil with the petrol, so oil passages are not needed. And if, like many 2-strokes, air cooling is used instead of liquid cooling, there's no need for coolant passages in the cylinder head. Another difference between 4-stroke and 2-stroke petrol engines is how they deliver air-fuel mixture to the cylinder. In a 2-stroke petrol engine, separate passages called ports let air-fuel mixture into the crankcase and cylinder and exhaust gases out. They're covered and uncovered by the piston as it moves up and down the cylinder. In the 4-stroke petrol engine, the inlet and exhaust ports are opened and closed by valves. These valves need a system to control how they work. The valve is held in place by a valve guide with a spring on its stem. A rocker arm is attached to a stationary shaft that allows the arm to pivot. The rocker arm compresses and releases the valve spring so that the valve opens and closes. Let's run the cycle again. The piston moves up the cylinder. The top of the piston covers the exhaust port, the bottom uncovers the inlet port. Air-fuel mixture enters and circulates in the sealed crankcase below the piston. The piston rises and compresses the mixture above it. A spark plug ignites it and it burns. Pressure from the expanding gases pushes the piston down in a power stroke. The top of the piston uncovers the exhaust port and lets exhaust gases escape. The bottom of the piston covers the inlet port and forces air-fuel mixture up into the now open transfer port. The piston reaches bottom dead center and the crankshaft forces it back up to repeat the process. Notice which events occur above the piston. compression of the air-fuel mixture into the combustion chamber, combustion for the power stroke, and scavenging of the exhaust gases. Notice the events that occur below the piston. Intake into the crankcase, pre-compression of the air-fuel mixture in the crankcase, and the transfer of mixture from the crankcase through the transfer port and into the combustion chamber.